just when you thought it was going to be a normal Monday.
Baby math, 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 baby math.
All right, baby Nyson, what do you want to be when you grow up?
I want to be a math teacher with the world's best students.
Are you good at math?
Mm-hmm.
Well then, what is the quadratic formula?
X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
What is 99 squared?
9,801.
Can you recite pi?
Yes. 3.14, Does that make me a cutie pie?
Whoa, it's good to be back to one's own self. You know, when I was young, I wanted to grow up and be an astronaut. But my dad would always say, son, the sky's the limit. So I guess I couldn't be an astronaut. So I became a math teacher. No, really, I could never be an astronaut because I suffer from acrophobia. I'm acrophobic. Acrophobia is the fear of heights. Well, maybe I don't have a fear of heights. Maybe I just have a fear of falling. You know, many people have told me, Mr. Nyson, if you could overcome your fear of heights, you'd be very influential. And I agree with them. I would have a great impact. But make sure you pick the attendance. It is Monday, May 18th. Make sure you get that attendance taken today and every day. And so welcome back. This is your e-learning store for this week. This will be our last week of warm-ups. This will be the last week for Khan Academy. And so if you get these 3 done, you're done. And so get them all finished up, get all that done. And so that's going to be this week. Also, we have logic problems this week. Next week, we only have 2 days to school. And so we're wrapping things up. And so you want to also be wrapping things up and get this extra credit done. Also, I haven't really been, I'm going to try this week to make it to Mrs. Wagner's lunches. And so if you want to show up, I've never been there before. Maybe some of you haven't been there either. And so it'll be good to maybe see everybody. And then also next week, the school has certain days and your parents will get all that information about when to pick up stuff that was in your locker. But it's not just about pick up. It's also about drop off. And you have a textbook of mine and some of you have some other things. In geometry, you have mirrors and compasses and I want the stuff back. And I might have some things to give to you. And so we'll let you know about that more. But next week, we're going to plan on being at the school for those 3 days. And they have it all alphabetized and things. And so even if you don't have anything to pick up because your locker's all cleaned out, you do have textbooks, maybe library books, and things of mine that we need back. And so just listen. Whatever the school says takes priority. But you can email me. But we do want to get some of our things back. And that will be next week, and it'll be good to see some of you one last time before the summer, okay? And so, but this is the beginning of the week, and we want to do logic problems also. Some of you signed up for that math contest. You can still check the link I sent at the end of last week, but it costs $15. It's a math count style competition. It's Wednesday, I think 4 to 7. You have to be proctored. There's a lot of specific things, but also you need to make sure that you were supposed to sign up for that maybe by yesterday. And so you can double check to see if that window's still open in case you forgot. But he who hesitates is lost. So don't put things off, especially in this time of being home. It's easy to put things off. Okay. So for logic problems this week, we have some of you like these. Everybody got these right. And they were 3 darts last time. And so this time we got 5 darts. Just don't be throwing the darts at me. Okay. And so if you have this, you want to pick 5 numbers that add up to 111. It's a little tougher when there's more of them. But you could, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. You can either figure out which 5 add up, or you could add them all up and then subtract what you don't need, as opposed to keeping track of what you do need. And so that's another way of thinking about it. This second one could be kind of tough. It says determine the number of squares of any size that contain exactly one odd number. And it doesn't matter if there's an even or not in it. It just matters if there's an odd. And I got to shrink myself down so we can see more of this stuff. Okay? So if we look at this, determine the number of squares of any size that contain exactly one odd number. And so the first question is, and you got 3 of them to do. So like this one right here is in how many squares? Well, it's in this square. That counts as 1. It's in this square. That counts as 2. It's in this square. It counts as 3. It's in this square. It counts as 4. It's in this square. Now that has an even, but it only has one odd number. That counts as 5. But if I include this square, that would have 2 odd numbers, and I can't do that. Now what you have to do is you have to do that for all these odd numbers. Like here's 1. Here's 2. But I can't do 3 because I would have 2 odd numbers. And so I'm counting how many squares have only one odd number in it. They can have an even. Then the question says, how many squares have exactly one even number in it? And that means it can have an odd. And so this one's in 1. It's in 2. It's in 3. It's in 4. Do the 2 by 2s. Then do the 3 by 3s. Well, you can't do this one because that would have 2 evens. And then you'd have to have this one. And then you'd have this one. And so, and then the third question states, how many, whoa, I got shrunk. No, not back to the little kid, no. And so, get the sound off my face. It says, determine the number of squares any size in the diagram that contain exactly one even and one odd. So you only can have one of each. And so, like this would have one of each. But then, that's an even and an odd. This one would have one of each. This one would have one of each. Okay? This one would have one of each. This one would have one of each. This one would have one of each. I think you're getting the idea. And you want to get the maximum. And the counting problems, I know some of you is like, this is not my favorite. I need to grow up a little. And so here we're back. And then on the backside, some of you have emailed me and said, Mr. Nyson, with no tests and quizzes, I don't get say what you sees. And Preston, I don't like say what you sees. It's okay, Preston. You can still do them. And so I thought we'd give you some for one last time this year, since we don't have any on the tests and quizzes. But we'll shrink this down. Not me. Whoa, what's happening? And so this says there are a bunch of problems at the bottom, and you need to find, I don't know what's happening today. Shrinking down, getting bigger, kind of strange. I'll put myself right here. And so you have to write all the say what you sees down here at the bottom. So the letter tells you how many letters are in the word. If it says 4-4, that's 2 4-letter words. Okay? If it says 10, that's a 10-letter word. And if you think over, under, on, you're going to get most of them. And the reason there's a word search is because maybe you could find the word up here, like I see the word coupons. Well, that's a 7-letter word. And these down here are in alphabetical order. See, I'm making it nice on you. Oh, that'd be this one. And I'm going to write it here. C-O upon S. And so that would be coupons. If I write right here, ab on. Oh, ab and on. And so that would be abandon. Now, can I find the word abandon up here? I want you to find them both places. And so they could be backwards, they could be reversed, they could be wherever. I don't know where abandon is. Ab, oh, here it is. Ab and on, abandon. Okay, so the word search is supposed to, you just like look and go, wait, I found a word, cloverleaf. I wonder where that is. I found campground. I found belittled. I found a by a small y, and that would be abysmally. And so you know the next one's going to begin with A, these are going to begin with B, This one's going to be campground because camp G, round, campground. And so you look through those, and even if you maybe say, I don't like say what you see, I'm telling you how many letters, I'm telling you they're in alphabetical order, and I'm showing you all the answers up here that you can just find them. Okay, so I know some of you have been missing those. And so work on those, get both sides done. This week might be worth more than 10 points and make up for having maybe being the last logic problems of the year. And so we might have something for you next week, but it won't be logic problems. And so, but we'll be wrapping things up. So these will probably be worth more than 10. And so you want to get them done, and that's a way to raise your grade. Okay? So logic problems, warm-ups, and now let's get to the notes. Geometry today. We're going to pick up one topic. Sometimes you would talk about this in physics, but it is in regular geometry curriculum. And we're going to talk about vectors. And no, we're not talking about Despicable Me. I got in trouble. You know, I would show the clip from the movie Despicable Me where Vector comes in and says, I have magnitude and direction. But then YouTube won't like that because we put a movie on here or something. So you just have to put up with me saying it. Or you can watch Despicable Me with Vector, who has magnitude and direction. We're going to spend a couple days talking about vectors, but we are going to be working and doing notes and homework all the way up to the end. We already had a bunch of days off. And so don't think we're going to take more days off. Some people are stopping. We're not stopping. And so your grades go all the way up. And so make sure you're with us every day. And so I only have 5 more opportunities with you. And so we want to take advantage of them. And so today's homework is in the book. It's going to be page 541. It's assignment 128, 1 to 9, 9 to 26, and problem 29. Okay? And so we also have the logic problems and warm-ups. But for the notes today, we're going to talk about what a vector is. And it has both magnitude and direction. And then we'll talk about how we add them and subtract them and graph them. And talk about component vectors. So a vector involves both magnitude, that's a length, the magnitude is a length, and direction. A vector always has to have an arrow. It has an initial point and a terminal point. And I hate it when I have to write all these words. Magnitude and direction. You can write them so much faster without having to do it on a mouse. And so a vector does have an initial point. That's where we get started. And we have a terminal point. And that's terminal, like the Terminator, means that's where the vector ends. And so initial and a terminal point. And so our book uses like older notation. And on the notes, I'm going to use the more standard notation. But if you had the point 4, -7, so write 4 down 7. Make sure I don't plot this wrong. So there's point P. And if Q was -1, 5, a vector is like drawing a segment. But it's kind of confusing because the segment's going to look like a ray, but it's not a ray. It's a vector. And so we're going to put an arrow on the one end. We're going to go right here to here, and we put an arrow. And did that have an arrow? It went the wrong way. And so we want the other arrow. We start at P and we go to Q. And the arrow goes that way. Okay? Now, so the way we call this, we would call it PQ. But a ray would have an arrow, at both ends. A vector, you just draw the half arrow. And that would be vector PQ. Okay? Now, starts at P, goes to Q, and it has a length. A ray would not have a length. It would keep going on. But this stops, and it has a direction. Now, people use vectors in things like, say, the storms and the rain. Here's like a map. It's so tiny. But this map shows like the wind vectors. And the stronger the winds, the longer the arrows, and the direction of the winds. And the smaller the wind, the shorter the arrow. And so they apply vectors to various fields. And one thing is weather, and we sure had a lot of rain. And so I don't know if it's done yet. So you can get all your e-learning done. And so vectors apply to that, and they apply to physics. And so if we get back to the notes, there are vectors. But then we want to call what's called a component vector. And all you're doing on a component vector, I should move it up here. I just get in the way sometimes. I got in the way back at school in front of the board. But, whoa, I don't want that. I need that back. A component vector is when you take the vector, and you just pick it up. Whoa, not like that. And why is the vector just... There we go. And we move it. Why won't this move? I want it to move. There we go. And you just move it. Sorry, it took a little time. And you move it to where the initial point is at the origin. And so a lot of times when it says the word component vector, we want to compare all the vectors and move the initial point to initial INI. Oh, I forgot the I. TIAL has an initial point as the origin. So what you're really doing is just moving it. Now, how could I move that vector and know what it is? So if I had a component vector, for example, we would call this component vector and we would use this type. You wouldn't use an ordered pair. Now your book still uses parentheses, but most people use these V's, like a greater than and less than sign. And that shows you that this vector, the point that we're giving you is only the terminal point. And so what would the terminal point of this vector be? Because the initial point is always going to be 0, 0. So the terminal point is going to be what, Grant? -5, 12. Now, how'd you get that so fast? Especially when it's off the graph. Oh, you mean you could just look at these? And since I moved it, it was down here at 4, -7. I just subtract 4 and I add 7 to this one. So -1 minus 4 is -5. And 5 plus 7 is 12. And that's how you would get the component vector. And then once you know the component vector, what is the magnitude? The magnitude's the length. And many times we put the double absolute value bars around it. And that says I want to know the length of the vector. Well, it's just the Pythagorean theorem. If you have the component vector, if your terminal point is -5, 12, that means this is 5. That means this is 12. And we got the old x component squared plus the y component squared equals the magnitude of the vector squared. And so it would be the square root of the x component plus the y component. And so the length of the vector is 13. And here we are with the Pythagorean theorem once again. Once you get all those things in your head, they're there forever. So don't let them turn to mush. On that. Now, the last part of your homework is, can you do vector addition, vector subtraction, and scalar multiplication? And so we're going to stay right here for now. And the first one is you have a vector. Now, when it's written like this, your book doesn't do it. But this would mean this vector starts at 0, 0. It's a component vector. And the endpoint is -2, 5. So here's your vector. From there to there. I could have used the straight edge, but I just drew it. Now, scalar multiplication means you're just taking 2 times each of these parts. You're going to make a vector that's twice as long. Well, if you made this vector twice as long, it would go, and when they say draw a picture, it would be twice as long. And so you could graph it, and you can go, well, that point would be -4, 10. And so my component vector that is twice as long is -4, 10. But notice how easy it is. You just multiply each part by 2. 2 times -2 is -4, and 2 times 5 is 10. That wasn't that hard. Now, we're going to have a scalar, or not scalar. You only do scalar with multiplication. But then we're going to do, whoops, I don't know where that line came from. We're going to do addition and subtraction. And some of this is on your Khan Academy stuff. How do I do vector addition? How do I do vector subtraction and things like that? And so I really need to fit in here. So I just want to fit in. And so if we graph v, negative 2, 5, that's a component vector. So here's v going from here to here. And then w is 3, 4. That's from here to here. But if you were going to add that, let's do this one first. If you were going to add two of these vectors, the easy thing is, if you were doing it mathematically, just v is negative 2, 5. And then 2 times w, well, instead of 3, 4, you would have 6, 8. You'd be adding the component vectors 6, 8. And then you just add them. You just add 6 plus negative 2 is 4. And 8 plus 5 is 13. Now in your homework tonight, it says not only find it, it says on some of them to graph it. It's like, I don't know why I'm doing this. It's pretty easy. Multiply this by 2 and add these, and that seems pretty quick. Doing some vector arithmetic. But then it says graphically explain what's going on. Well, here's your negative 2, 4. And if you were going to add this one, your 3, 4, you add it to the end of it, because that's where you are. I'm at my terminal point, and then I add my 3, 4. And I wish this thing would work. And I would add another from this 3, 4. I would add another 3, 4. Well, I should have it blue. Sorry about all these little technical difficulties. Well, where do you end up if you take vector v and add 2 vector w's? And when you add and subtract, you always add them on to the end. And where would you end up? Well, guess what? I'd end up right here at 4, 13, which is the component vector 0, 0 to 4, 13. And see, this vector right here is the vector 4, 13. And so v plus 2 w's ends up at 4, 13. And we have a graphical representation of that. What if I had w, which is 3, 4? And I wanted to subtract negative 2, 5. Kaya, what is 3 minus negative 2? Yes, that'd be 5. And what's 4 minus 5? Negative 1. Excellent job. And so this would be 5, negative 1. Now let's see if we could do this and end up at 5, negative 1. Well, vector w is the one we're starting with, 3, 4. So here we are. We're at 0, 0. The component vector is 3, 4, and we end up right there. Now, if we're going to subtract negative 2, 5, negative 2, 5 normally would be right here. You go left 2 up 5, and we'd end up here. But if this is vector v, the vector opposite of v, because subtracting is adding a negative, it's like doing a half turn using all these geometry words, and we would end up right down here. And so we're really taking vector w, and subtracting is really adding the opposite of the vector, and we end up right there. And so my component vector really is 5, negative 1. And that's where we ended up, right 5, down 1. And that is the vector of w minus v. And that's how you should draw it on your homework. You should do the math, which is very easy, but then graphically representing what's really going on here, okay? And so now let's take a look at the homework. That was short notes. And so the intro was longer than that. And so on tonight's homework, it says, not the class exercises, but the written ones, it says to graph. Now, here's AB, and that you'd plot point A, you'd plot point B, but then you want to move it to the component vector. So when it says find vector AB, that means find the component vector, and we'd write it like this, where it starts at 0, 0. And so if we're at 1, 1 and we end up at 5, 4, wouldn't we just subtract and my component vector would be 4, 3? And the odd answers you can check in the back of the book. Now your book writes the magnitude of the vector like this. We would write it with the double arrows. That's the more contemporary way to do that. And you could call the component vector V, or you can call it AB, but we usually do the double bars around it. And if it's a 3, 4, what's your Pythagorean theorem? 3 squared, 4 squared equals 5 squared. Very good. And so you do the same thing on all of them 1 to 9. And yes, it might take a little bit to draw the picture, but it shouldn't be too much, okay? Now, when we get to the second part, 20 to 26, way down here, find the vector sum. These should really be written like this with the brackets, or the greater than, less than signs. This is starting at 0, 0, and we're going to 2, 1. Then from that, you go right 3 up 6. Well, if you go right 3 up 6, your final answer is right 5 up 7. And so drawing the picture doesn't take that long. It doesn't have to be the whole X and Y coordinate system. It can just be quadrant 1 if that's all it needs. Then problem 21. And so all the way to 26. Now 26 says two forces. See, this gets to physics. You have AB pulling on an object, and you have AC pulling on an object. Well, it has the same effect as the forces of their sums. Why is the diagonal the sum? This is all you have to do. You take this right here and say when you add vectors, you just move it right to there. And so y is, if I pull this way and I pull this way, it's really like adding them, and this is where I'm going to end up, right there. And it's commutative. I could have added vectors this way, and then I could have moved this one down here, and I would still end up there. And so vector AB plus vector BD is equal to vector AC plus vector CD, because AB is an equivalent vector. This vector would have the same component vector as this one. And this one right here would have the same component vector as this one. So we call those equivalent vectors. Okay? I have magnitude and direction. Okay? And then the very last one, problem 29, it says complete the diagram. M is the midpoint of AB and T is the trisector of AB. So what is AB? So what you want to do is, this is a component vector. You want to change this point to 0, 0. So just subtract 2 from each of these. It's going to be 18, 18. Well, if it's 18, 18, can you divide 18 by 2? Can you divide 18 by 3? And I think you're done. Okay? And so you can find all these component vectors. Okay? And then that's it. Tomorrow Wednesday, we're going to find angles between vectors. And just the purpose of this is not Physics 1, but it is in the geometry standards. And the purpose is to introduce you to the concept of a vector. It has both magnitude and direction, and the math behind it is not that tough. Graphing them, you're going to lose some points if you don't graph them. So make sure simple graphs of just adding the vectors so I can see how you know to add them on to the end. Then everything's fine. Okay? So we miss all you guys. I haven't been to any of Mrs. Wagner's lunches. I'm going to try to make it this week. And so some of you have been very faithful going, and some of you haven't. Maybe there's only been a couple of you. And so hopefully you'll be able to make it, and we'll just crash the party. Okay? She always invites, and sometimes trying to get all the school stuff done, it's hard to be there. But hey, and we have the contest Wednesday night for those of you that signed up. And so don't forget that. And so get everything done on this rainy day. And we miss all you guys. Bye-bye.